We are always trying to make sense of the world. The world is a strange and complicated and sometimes beautiful place, but what we are realizing is that sometimes what we thought we knew about it was actually wrong. And this is the case, perhaps, for anxiety. Anxiety is almost universal. About a third of people will experience an anxiety disorder at some point in their life. Anxiety, from an evolutionary perspective, helps scan the environment for threat, for danger. It is an alarm system that we need, but sometimes this alarm system goes wrong. We all have had the experience of feeling anxious. Perhaps what we thought we knew about anxiety is not actually true. We assume that the threat is from the outside world, that anxiety means danger or catastrophe. But perhaps it is our brain-body connection that is making us feel anxious rather than the outside world. So, sometimes we might be thinking, my boss, they must think I'm really awful, or my partner doesn't love me. But maybe we are interpreting the wrong cues. So anxiety is essential. We need it from an evolutionary perspective. We need adrenaline sometimes to get things done. But the problem arises when we experience it too much, when we can't switch out of it, when it becomes problematic. Brain is a prediction machine. The entire body, as it is designed, body and brain, is to make things as efficient and safe as possible, to survive within predetermined limits. And in order to do this, we need to make predictions. And sometimes those predictions go wrong. When they go wrong, we get this mismatch between what we think is happening and what is actually happening. And when we get this mismatch, this glitch, it's expressed as anxiety. Anxiety is the perfect example of where brain and body collide. And although we're all familiar with anxiety, where it gets confusing is what diagnostic label means what. So I'm going to talk to my dear colleague and collaborator, Dr. Nick Gray, a clinical psychologist who is an expert in anxiety research and treatments.
We need anxiety because it keeps us safe.
You mean from an evolutionary perspective?
Yeah, absolutely. From an evolutionary perspective, if we weren't able to identify possible dangers, then we would be at risk. Yeah, at risk from predators out there, and I was also thinking then kind of at risk from one another. Yeah, we need to be thinking about kind of those kinds of immediate risk, and that's a physical risk. But certainly, what's more, I think, kind of more prevalent typically in our day-to-day life of the population is not just physical risks, but also what we might perceive as like social risks. How do other people see us? How do we see ourselves? And we may have kind of concerns about how we're coming across. And one of the most common kind of anxiety problems that kind of people may have, if we're then getting into the different types of anxiety, is kind of social anxiety, or when it becomes significantly distressing or impairing, might be referred to as social anxiety disorder. The other main common ones, probably actually the most common one alongside social anxiety, are kind of specific phobias. So about 1 in 10 people have a fear about specific objects or situations like spiders or heights or closed spaces. And actually these are kind of normal fears that people might have. And for most people, for most of us, they don't significantly interfere with our life. They don't stop us getting on with life and living as we wish to, or they're not significantly distressing. But if they do impair our lives, or they are particularly distressing, then it would sort of almost, again, attract the label. It's a specific phobia, and it's about 1 in 10 people who kind of would have that. So specific phobias and social anxiety are probably the two most common anxiety difficulties. Then alongside that, there are kind of other ones, such as one which is really characterized by worry. And again, worry being a normal process, but when it becomes more out of control and again impairing what people are doing, getting in the way of just living one's life because you're spending so much time in your own head worrying about things, then it might meet criteria for what's called generalized anxiety disorder.
Yes.
And that's probably almost like the next most common kind of anxiety problem under the sort of anxiety umbrella. And then there are sort of some anxiety problems which are less common, but typically very significantly impairing, such as kind of panic disorder, where people were having kind of like regular, unwanted, out of the blue panic attacks. And by a panic attack, it's a sort of a sudden rush of physical symptoms, such as, you know, kind of feeling kind of dizzy, heart racing, kind of faint, sweating, a range of other physical symptoms that come on in what's sometimes referred to as like a crescendo of fear.
But a very bodily experience.
And anxiety as a whole is a physical experience. All of our emotions are physical experiences. They're not just kind of, you know, what we think in our heads or kind of almost like what we perceive as the emotion of it, but physically, absolutely, it's kind of impactful.
If there's anything I've learnt in my years of being a psychiatrist and a researcher, it is that everyone is different. Everyone responds differently, everyone is different. And that is why it is so important to understand brain-body differences.
My almost like very first job after graduating in psychology, it was just sheer chance. I was working at the National Spinal Injury Centre at Stoke Mandeville.
Oh, wow.
So I was working on a research project with kind of sort of senior colleagues looking at kind of coping with spinal cord injury. And what really struck me is, although people sort of had ostensibly the same kind of event where, you know, essentially paralysed to various degrees, how they coped and how they functioned afterwards, and how well they functioned afterwards, was such variability. And that was kind of fascinating about, you know, what was it that both individually but also in their family or in their systems that helped some people really kind of deal with, you know, some of the worst circumstances you could imagine, and others it was just much more challenging.
So why this variability in emotional expression? Professor Sarah Garfinkel at UCL is one of the world's leaders in the neuroscience of emotion and interoception, the inner sense of what is happening in the body. She is also one of my best friends.
As an emotion researcher, I am definitely of the opinion that our emotions are shaped by our bodily responses.
Exactly.
And now we're in a situation where body responses differ so differently in different people.
Yes.
Some people are so reactive and some people
Trigger happy, nervous systems.
Yeah, show them something emotional and you get all of these rapid changes in all different bodily organs. And we can see this in the lab.
Yes.
And other people just do not have these reactive bodies in the same way. And those people with the reactive bodies, as informed by your lovely work, are more likely to be hypermobile, more likely to be neurodivergent. And you can then see that they can maybe feel emotions more deeply, or they can be overwhelmed by emotions and potentially dissociate.
Exactly. And you remember, because we used to share an office when I was doing my PhD and you were doing your postdoc work, that we did this brain imaging study on hypermobility and anxiety. And you know, you've been involved in that, and that the kind of headline finding in terms of the hypermobility and the anxiety was not only the differences individually in terms of the physiological responses, so what was happening to heart rates when you stood up, but what the main brain imaging findings were is that the frontal part of the brain was not engaging in hypermobile, anxious people. This control center was kind of less switched on, and that these sort of fiery emotional parts of the brain, like amygdala and insula, were in overdrive. The balance is off.
It is. And although the balance is off, I don't want to make it sound like it's a negative thing. I think, and I know you do as well, think it's a beautiful thing that these hypermobile people are more reactive, because actually they're sharing other people's joy, pain, fear, sadness.
Yes.
They are having a heightened response to that. And that's actually the whole basis of the empathy response that binds people together. And that's actually such a beautiful thing, that someone else can have such a strong emotion in their body and brain in response to the emotion of someone else or something else.
This is a longitudinal study in the Alspat birth cohort that shows that if you're 14 and hypermobile, you're more likely to experience anxiety and depression at 18. We have recently published a functional imaging study of hypermobility and anxiety. So we had an anxiety group, a non-anxiety group. Half of each group we tried to sample so that they were hypermobile. It's actually very hard to match all of that, but we had some really interesting findings. So what we found was that the hypermobile group compared to the non-hypermobile group basically didn't activate frontal cortex to emotional images. So they are not exerting the executive control that people normally would. And that the hypermobile anxious participants were activating amygdala and insula in response to these emotional images. And so what this suggests is that there is abnormal frontolimbic reactivity in hypermobility that may explain anxiety, and that a similar pattern is actually seen in ADHD.
And maybe this is a good time to talk about interoception.
Yes.
Because
this is really what you're known for, interoception.
Yeah, it is. And it was through looking at individual differences in these bodily signals that got me interested in interoception.
Yes.
So interoception is the sensing of these bodily signals. And sensing can be conscious sensing. Oh, I'm aware of the fact my heart is racing, or I'm aware my tummy's rumbling and I'm hungry. Or it can be the pre-conscious sensing. So that can be like, you might be feeling anxious, but you don't know you're feeling anxious, and you don't know why you're feeling anxious.
But something's off.
You
can tell that something's off.
Yeah, exactly. So maybe the body is responding in a heightened way, and you know it's off, but you don't know what and why. So it can also be just the neural sensing, because actually our brain is dynamically coupled to organs on the body. You have organs in the body through the afferent pathway. That means
so afferent pathway
is body to brain.
Yes.
And
arriving begins with an A.
Yes, that's
and
good.
Efferent, exiting.
Exiting, that's brain to body.
Yes.
But through the afferent, body to brain, these organs are sending signals that are activating and shaping brain activity.
So Sarah, you wrote a very seminal work about interoception, which changed the field. We had previously thought of interoception as this kind of one big concept of this inner sense in the body.
Yeah.
But you showed that there were different elements to interoception. What did you show?
Well, the more time goes on, the more levels I add.
Yes.
So it's complicated, but I'll give a summary.
Yes, summary.
Yeah. So I have at the very lowest level the nature of afferent signals. So it's
the arriving signals, what's in the body itself.
Yeah. And I have that as a distinct level because those signals can look very different in different people.
That is just a question of nerves, electricity, and signals.
Yep. Yeah, but also to make concrete, we can maybe see how your resting heart rate, your heart rate variability, we can look at how fast, how much your heart is pumping, how big that signal is. We can even measure gastric rhythms, look at...
So it's the very basic bodily processes.
Yes.
And then the level above bodily processes.
So then we can have the... neural sensing of them. And neural sensing just means if I were to scan your brain, what does the brain activity look like specifically in relation to those bodily signals?
Yes. So to the bodily responses, what is the brain reacting to the bodily responses?
Yeah, exactly, that's right.
The brain activity, so like sleep waves or like epilepsy waves that we can see, they are the brain waves. Heartbeat evoked potentials are the influence of the heart in the brain.
Yes.
So you see the heart in brain waves.
You do. And what's interesting is how big that signal is different in different people.
Yes.
So in individuals who find it hard to regulate their emotions, there's some work that's shown that brain signal is smaller. So the heartbeat signal in brain. So we can quantify other levels of interoception, like interoceptive accuracy, which is what I made a distinct level in my model. And that means if I bring you to the lab and monitor a signal in the body, how accurately can you detect that signal?
Yes, and you could do that potentially with a pulse oximeter, or you've done it with breathing, and you know how difficult it is to breathe in and out.
Exactly, we can do it for different organs in different ways using
or how full you feel in the stomach. There's all sorts of experimental manipulations.
But what's important is that we have actual measure of what the body's doing that we can have a readout of. So we have something to compare it to.
And so this is the readout.
This is a readout. Is what you're reporting,
what you're feeling, your self-report of your sensation. Do they match up?
Yeah.
And so what did you show?
What I showed is that they don't always match up for
They don't always match up.
They do not. That actually people can have quite strong beliefs or thoughts that they are detecting something, and actually when we look at the readouts, they don't match.
So what you showed and what we took into the ADAPT study in hypermobility and anxiety was that there was this discrepancy.
Yeah, and so those individuals who actually have the biggest gap between what they think their body's doing and what their body is actually doing, because it's very hard to have those two align, and they're often mismatched.
But if there is a discrepancy...
So my work shows, and I think it's complicated, and it may be different for different symptoms, so I don't think we understand it fully yet. But the way that I see it from my work, specifically in relation to anxiety symptomatology, is that if you have this very high awareness of what the body's doing, but when we test you in the lab, your accuracy is low, if the awareness is higher than the accuracy, the extent of that gap maps onto heightened anxiety.
Yes. So maybe when you're feeling anxious, we must look within to work out, is it really anxiety? Why are these alarm bells going off? So alarm bells can go off all of the time, but it doesn't always mean that there is actually danger. So for the hypermobile neurodivergent body with lax connective tissue, a trigger-happy involuntary nervous system, prone to fight or flight, small things that you might not even realise, like standing up too quickly, having a large meal, being in a hot environment, they may trigger a bodily cascade that feels like anxiety. But is it actually anxiety? It feels like it, but it's actually the variability in the system and the communication between body and brain that is going wrong, rather than a threat from the outside world. Now, as prediction machines, we want things to be certain. Uncertainty is terrible for neurodivergent people. Tolerating uncertainty is really difficult. And when you have a body that means that its responses are variable and uncertain, you may interpret those cues as anxiety. But actually, it may be that your clothes are too tight, that you're too hot, that your blood sugar is too low, that you haven't had enough to eat, that you haven't had a pee. Neurodivergent hypermobile people often hyperfocus, and when they hyperfocus, they forget to eat. So sometimes we think we might be anxious, but we might be getting it wrong. It might actually be that we're hungry, that we haven't had anything to eat, that we're thirsty, that our joints aren't stable, that we haven't had a pee. So by tuning in to what the body is telling us, we may be able to regulate our emotions. What we thought was anxiety may actually be something else after all. In the next instalment of Bendy Brain, we'll be taking a deep dive into the involuntary nervous system. Do you often feel dizzy or lightheaded when you stand up? Well, we will be diving into postural tachycardia syndrome and also practical strategies to help manage anxiety and regulate emotions, brain-body style.